Welcome back. Today we are going to be looking at lesson 4.1. It is going to be the introduction of a piecewise function. Now today's is going to be broken up into two different videos. Video 1, we're going to talk about what is a piecewise function and how do we evaluate one. And in the second video we'll be talking about how do we graph a piecewise function. So a good place to get started in is what is a piecewise function? Well, sort of simply put, what we have here on the screen is our piecewise function. A piecewise function is merely two different equations that are graphed on the same graph, such that when one equation stops, so here we have this first equation being drawn from the bottom left to the top right. Ooh, we're hitting some buttons here. We have that first equation being drawn. When that first equation stops, that's this y equals x minus 2. When that first equation stops, the second equation takes over and starts being graphed. So a piecewise function is when two or even more, you can do 3 or 4 or 5 equations, but when you have 2 or more equations that are put on the same graph with each other. That's what they kind of look like, and today we're going to talk about evaluating them, and in the next video we'll talk about how to graph them ourselves. So, again, piecewise functions, 2 graphs, 2 equations, 1 graph. So, if we're being asked to graph a piecewise function, what does that mean, or evaluate? So here we have a piecewise function. Looks like 3 different parts to it. And we're being asked to find what is the value at f of 4. So for this problem, to evaluate this, we're going to go to the x value of 4. And we're going to see, hey, what is that y value when x is 4? And right there, that's where our graph is. That's the line that happens. So when x is 4, that y value in this case is going to be negative 4. And there's my solution. How about if I said, what's the value when, I don't know, if I do f of negative 6? When x is negative 6, what is that y value? Again, I would go to x value of negative 6, follow it till we hit the graph. Oh, there we are. What's that y value? Negative 8. So if I evaluate the same function, the same piecewise function at negative 6, at negative 6, my y value is negative 8. How about this one? Let's try one more. What happens when our x value is positive 1? So again, positive 1 right here. Let's see. If we go down, something interesting happens. There's 2 points. There's this closed circle. Let's use there's this closed circle, and then there's this open circle. Well, which one are we going to use? Well, if you recall back a couple lessons ago, when we were graphing our inequalities on a number line, the closed circle meant we would use the point, and the open circle meant we were not going to use the point. It's a matter of which one do we include. This is going to apply here for these piecewise functions as well. We're going to use that closed circle point. We can see what's that y value then? Negative 7. We've just evaluated our graph. We've just evaluated the piecewise function at 3 different points. Now, what happens though if we're not given a graph? Let's just say we're given an equation. Let's make this so this is nice on the screen for us. How about we have this equation here? Now, this equation has 3 different parts. That's fine. That's fine. But what we're going to do for it says find f of 3. So that's saying when the x value is 3, what's the answer going to be? So if I were to put 3 into this equation, what's the answer going to be? Well, the first thing we need to do is we need to figure out which of these 3 equations we're actually going to need to use. So if we're saying when x is 3, we got to evaluate. Does a positive 3 fall within that first interval? Negative 6 less than x less than 3. Does positive 3 fall in the interval? No, it doesn't. So we're not going to use the first interval. How about the second one? Is positive 3 equal to 3? Well, it is. That is true. This is true. When 3 equals 3, that's a true statement. So this is the equation I'm going to use. And now for us, this problem it has no x's in it, so my answer is just going to be -5. But so on the right, we have our domains. It is what are the value of the x value. So when you're solving a piecewise function without a graph, you're going to see what our value of x, which equation or which interval it fits in, and that's going to determine which equation we're going to end up using. So let's try, let's do this one down here. Yeah, I like this one here. So again, if I want to evaluate this piecewise function, I am going to look at my x value of -5. I'm going to see which interval it plugs into. We're going to see which interval it plugs into. Is -5, if I do -5 less than x less than -1, well, does -5 fit in the interval? No, it doesn't. -5 is equal to -5, but that inequality doesn't have the equal sign. Is -5 equal to -1? No. Is -5 in the interval between -1 and +5? No. There's no point there. So our solution, if I could spell my words right, undefined. Ooh, there was nothing to put it in. Let's try this last one. If I could scroll correctly, that'd be helpful. Bear with me for just a moment. How about this one? If I said, all right, find when solve for f of x when x is 3. So again, I'm going to look to see which of these intervals 3 falls into. 2 less than x less than 6. If I put a 3 in here, is that a true statement? Is 3 between 2 and 6? Well, it is. This 3 falls in that interval. That means this is the equation we're going to use. Now, it just so happens, again, this time, there is no x's in the equation. So my answer is going to be -4. Consider, though, if you would have had the problem f of, 10. F of 10. 10, if I were to evaluate f of 10, 10 falls into which interval? Well, if you look quickly, 10 falls into this last interval. 10 is greater than 6. So because this is the interval that 10 works for, that means we're going to evaluate using that equation. So I would plug in 10, -10 minus 7 squared. And personally, I would just take that, I would throw it in my calculator, I would evaluate it out, and if you were to evaluate that out, you would get -9. I would encourage you to try that on your own. Try that math on your own. But for piecewise functions, what we're going to be looking for is, given our x value, which interval does it work for? And depending which interval it works for, that's the equation we're going to solve. So as we continue on, we'll see multiple different types of equations. And same deal, the same thing's going to happen. We're going to graph them, we're going to end up graphing them, and we're going to see which intervals our solutions are going to fall into. In the next video, we're going to look at how to actually graph these piecewise functions. I hope you do well. Take care, and I'll talk to you later.